You know, 1.6 is next, which are other types of equations. So other, and you can see the types we're going to go through here in 1.6. So I'm just going to do an example of each one of those so that you can be familiar with what we're talking about. So polynomials first. Let's look at number 4 on page 178. So this is now section 1.6, other types of equations. So we've dealt with linear equations, we've dealt with quadratic equations. Linear equations have a highest exponent on the x of 1. Quadratics always have the highest exponent is 2. Now we're going to look at other types of equations. So polynomials mean exponents. And a quadratic is technically a polynomial. A linear equation is technically a polynomial. We just call anything over 3, the highest exponent of 3, sometimes we call a cubic equation. But they're all technically polynomials. When we get to higher degrees, we just call them polynomials. So that's what we're doing here. First case, polynomials. All right, so what did we say? Number 4 on page 178. This is an example of a higher degree polynomial than we've dealt with so far. So notice the highest exponent here is 3. On the x, we call this a cubic equation. Again, it's technically a polynomial. X minus 27. All right, so first thing we want to do, similar to what we did with the quadratics, is bring everything over to one side and set it equal to 0. And it's a good idea to get into the habit of when we do that, when we bring everything over to one side, to have it in what we call descending order. So highest exponent first, next highest exponent, descending until we get to the constant value. So here we're going to leave the 4x cubed and the 12x squared on the left-hand side. Then we're going to subtract 9x from both sides, and we're going to add 27 to both sides. So notice highest exponent 3, then 2, then 1, then the constant term. All right, so to solve these, again, many things we do in this class deal with factoring, right? So again, that's in the prerequisite chapter. That's something you have to know coming into the class. If you're weak on factoring, you really need to go back and reread those sections, practice factoring, because it's going to come up again and again and again and again. So here, again, remember our factoring methods. First we look for a greatest common factor between all the terms. Doesn't look like there's any greatest common factor here. Even, these even numbers, odd numbers, there's 2, 3, 4, nothing goes into all these numbers evenly. There's not an x in every term, so there's no x common to all the terms. So there's no greatest common factor. Then we look for perfect square trinomials, which we dealt with in the previous section. This is obviously not a perfect square trinomial. This is not a difference of squares or a difference of cubes, any of the special cases of factoring that we cover when we teach factoring. Whenever you see 4 terms like this, hopefully if you've done any factoring in your life, you start thinking about grouping, the grouping technique. Now it's not always going to be the first 2 terms and the last 2 terms, but that's generally what you want to try first. So if you isolate the first 2 terms, and then look like you're adding the next 2 terms, right? So we're adding a -9 and we're adding a 27. I like to put the plus there and then separate the last 2 terms. So remember grouping, what you can do is you can look at the first 2 terms and take out the greatest common factor. So the greatest common factor here looks like a 4 for the numbers and 2 x's, right? So if I take out a 2x of 4x squared, from just these first 2 terms, I'm left with x minus 3. Right? 4x squared times x, 4x squared times -3. Okay? Now this is the reason I put the plus here and separate it so that I can do this. Let's put this in a square set of parentheses, just to keep everything, more parentheses the better to keep things in order. Now the trick here is we want this same binomial factor to show up here when I factor out of here. Because then I'm going to factor that binomial out of this product and this product. Okay? So I took the 4x squared out of here and was left with an x minus 3. So now, the greatest common, it doesn't have to be the greatest common factor, but you want these factors to match. So you want an x minus 3 to be over here too. So if I take out a positive 9 from here, I'm going to get negative x minus 3. I don't want negative x. I'd have negative x plus 3, right, if I took out a negative 9. Well, I don't want negative x plus 3. I want positive x minus 3. So you've got to factor out the correct value to get the same binomial here. So I'm going to factor out a negative 9 and take out a negative 9, or a negative 3, sorry. No, negative 9, I was right. Sorry, negative 9. So I take a negative 9 out of negative 9x, I'm left with that positive x, and I take a negative 9 out of positive 27, and I get that term that I want. I want this and this to be the same. Okay, so if you took out a positive 9 here, it wouldn't work. So that's kind of the, where the skill comes in. You've got to factor out the correct number so that this binomial and this binomial are the same. So now we're looking at the product of these two factors, this one and this one, plus the product of these two factors, equaling 0. So we have a common factor between this product and this product of x minus 3. So just like if I had AB plus CB, I could take a B out and be left with A plus C. Same thing here, it's just what I'm taking out happens to be a binomial. Right? So I'm going to take the x minus 3 factor out of this product and out of this product. So I'm going to get that common factor of x minus 3. I take it out of this product, I'm left with 4x squared. I take it out of this product, I'm left with minus 9. And I still got the 0 over here. Now we want to factor completely. So, now actually you could solve it from here, but it's better if you factor everything completely. Because now we have the 0 factor property, right? We got one factor times the second factor equals 0. So now we're right back to the 0 factor property. We can solve each one of those factors and come up with our answers. Another thing I should mention is the highest exponent is going to tell you how many solutions you're going to get. Okay, so remember for the quadratics, sometimes we get to, even when we got one answer, it was a double, right? It was something squared. So we got the same answer twice. Okay? So here we're going to get 3 solutions. Sometimes they might be all the same number, right? If it's a factor raised to the 3rd, we get the same number 3 times. But that's a clue as to how many solutions you're going to get. So notice here we're going to get 1 solution here, and we're going to get 2 more from this one. So you can go straight and solve this for 0 and use the square root property, or you can factor this further. It's just easier, it's good practice to factor, and it makes it easier if you keep factoring. So here I'm going to say x minus 3, and then this is the difference of 2 perfect squares, right? Remember the rule that says if we have the difference of 2 perfect squares, that can be factored into the sum and difference, the product of the sum and difference of their square roots. So you notice here, perfect square, square root is 2x. Here, perfect square, square root is 3. So this can be factored into 2x plus 3 and 2x minus 3. So now again, 0 factor property just happens to be 3 factors. We're going to solve this one. Say, when does this equal 0? When x equals 3. When does this equal 0? When 2x is negative 3 or x is negative 3 halves. And when does this equal 0? When 2x equals 3 or x equals 3 halves. So we got 3 different answers, right? 3 positive 3 halves, negative 3 halves. Shut it off for a second. Okay, 1.6, continuing with radical equations. Okay, so 1.6 still, other types. This is a radical equation, obviously involving radicals. Number 16 on page 178. All right, so we get square root of 6x. That's number 16. 16, 6x plus 1 equals x minus 1. All right, so notice this is a equation involving radicals, so we call this a radical equation. So the way we attack this is to square both sides. So when we had the square root property, we were taking the square root of both sides when something was squared equaling a value. Now we're kind of doing the reverse of that. We want to get rid of the square root sign, so we're going to square both sides. So we're going to take the left-hand side and square it, and we're going to take the right-hand side and square it. Now, hopefully we remember that square root of a times square root of a is just going to be a, right? So if we square something that's underneath the square root, we're just going to get what's underneath the square root, right? So on the left-hand side, we're just left with 6x plus 1. Now over here, avoid the most common mistake in all of algebra. This does not equal a squared plus b squared, and that is, I think, by far the most common mistake in all. It looks like it should be true, right? But it's not, right? A plus b squared, you got to remember that you're multiplying the a plus b by itself using the FOIL method, so you're going to get a middle term, right? AB and another AB, so you get 2ab plus b squared, right? So that is the correct answer to this, not a squared plus b squared. And that's what's going on here. A lot of people will just say this is x squared minus 1, and that will screw up the whole problem. So you got to be careful here. We're saying x squared minus 2x plus 1, right, using what we just showed over here. So now we just have a quadratic equation. Now we're back to where we were with quadratic equations. So we use any of the methods we just learned in section 1.5 to solve this. It's up to you to choose which method you want. So again, remember we said we want everything on one side and 0 on the other side, and we want to keep that positive number in front of the x squared. So let's move all of this over to this side and set it equal to 0. So we get 0. On the left-hand side, we got negative 2x, and we're subtracting another 6x. So we get negative 8x. And we got a plus 1, and we're subtracting 1, so there's nothing, no constant term left. So now you have choices, right? You can always use the quadratic formula here, but that's probably the least best choice here. It's zero factor property is usually the first thing you want to check, because that's going to be your easiest method, I would say. And here it looks like we can use the zero factor property by factoring out an x from both of these terms, right? If I factor an x out with both of these terms, then I'm just left with x times x minus 8. So I have one factor of x times one factor of x minus 8 equaling 0. That's the if statement of the zero factor property. So now we get one of our solutions is 0, and the other solution is 8. All right, so radical equation. When your equation involves radicals, you square both sides of the equation to get rid of the radical sign, end up with a quadratic equation, set that quadratic equation up in general form, solve it with any of the methods we discussed in chapter 5. Again, always good to check your answer, and actually, that's a good point. Sometimes it's even more important to check these answers, because sometimes your answer is going to give you an imaginary number here, and you won't be able to accept it. So it's very important to check these. If we put 0 in here, we're going to get the square root of 1 equals negative 1, right? Which isn't true, right? Square root of 1 does not equal negative 1, right? Does it? Negative 1. Negative 1 times negative 1, I guess that could work, right? The square root of 1 is plus n minus 1. So I guess we can accept that one. And what about 8? If we put 8 in, we get 48, 49. Square root of 49 is 7, so that works, right? So very important to check your numbers. And generally we're gonna assume positive square roots most of the time. So for the 0, it's kind of questionable. Square root of 1 equaling negative 1. Technically that's true, but most of the time we'll assume a positive square root. Either way on this one, I would probably give it to you, since there's a kind of a fuzzy line there. All right, so that's a radical equation. Now, there is a case where you have to do this twice, and I think I'll skip that for now and see maybe if it comes up in one of our homework question sessions. All right, so that's radicals. How about rationals? We want to deal with rational exponents. All right.